Mega earthquakes or megathrust earthquakes are the most powerful seismic events on Earth, often exceeding magnitude 9.0. They occur at subduction zones where tectonic plates collide and one dives beneath the other, releasing energy on a scale that can reshape coastlines and unleash tsunamis. Japan, perched at the intersection of four major tectonic plates, is especially vulnerable to these colossal events. The term, the big one, is a constant reality in Japan, referring to the anticipated mega-earthquake along the Nankai Trough. This is not a matter of if, but when, a fact that has shaped Japanese culture, engineering, and daily life. The archipelago's dynamic geography means stress is always building beneath its surface. When released, this stress can violently shake the nation, making Japan a cradle for devastating earthquakes. Understanding this threat is the first step toward resilience, not fear. In Japan, respect for the Earth's power is woven into society, from skyscraper design to school drills. The Specter of the Big One drives innovation, research, and a collective commitment to preparedness. This story explores the science, challenges, technology, and practical steps Japan takes to face one of nature's most formidable forces. Japan sits atop a volatile crossroads where four tectonic plates collide, making it one of the world's most earthquake-prone regions. The main culprit is subduction. The Pacific plate plunges beneath Japan, building up immense pressure along the fault lines. These plates don't move smoothly. They grind, stick, and store energy for decades or centuries. When the stress finally releases, the result is a violent earthquake. The longer the plates are locked, the more powerful the quake. Mega-earthquakes occur when a long segment of the subduction zone ruptures all at once, as seen in 2011 and feared along the Nankai Trough. The Philippine Sea Plate also subducts beneath Japan, creating a complex web of faults. This means earthquakes can strike both offshore and inland. The relentless grinding of these plates is the engine behind Japan's seismic vulnerability. It's a continuous process, loading the faults with energy that will inevitably be unleashed. This dynamic geology is why Japan must always be ready for the next big shake. The nation's seismic reality is a direct result of its place on the world's tectonic map. Japan's history is marked by devastating earthquakes, each leaving a lasting impact on its people and landscape. The 1923 Great Kanto earthquake struck Tokyo, Yokohama, causing massive destruction and deadly fires that claimed over 100,000 lives. Centuries earlier, the 1707 Hoei earthquake, a Nankai Trough megaquake, triggered a catastrophic tsunami, killing tens of thousands. These historical records help scientists estimate how often great earthquakes strike, shaping modern hazard assessments. The 1995 Kobe earthquake, though smaller in magnitude, devastated a major city, exposing weaknesses in building codes and emergency response. Over 6,400 people died, prompting a nationwide overhaul of seismic safety standards. The 2011 Tohoku earthquake, magnitude 9.0, was Japan's most powerful on record. It unleashed a colossal tsunami, inundating coastal towns and causing the Fukushima nuclear disaster. Nearly 20,000 lives were lost, and the event forced a rethinking of what's possible in terms of earthquake and tsunami risk. Each disaster has driven improvements in engineering, preparedness, and scientific understanding. Japan's seismic history is a guide for its future resilience. The lessons of the past are never forgotten. They shape every aspect of how Japan prepares for the next quake. The nation's story is one of adaptation and determination in the face of relentless natural forces. Seismologists act as detectives, using sensitive instruments to listen for the Earth's subtle signals. Japan's dense network of seismometers and GPS stations tracks tiny tremors and slow ground movements, revealing where stress is building. By mapping these microquakes and monitoring crustal deformation, scientists pinpoint active faults and locked zones. Geological records, like ancient soil layers disturbed by past quakes, help establish how often major ruptures occur. Paleoseismology, studying these layers, creates a timeline of past megaquakes, informing long-term forecasts. Researchers also experiment with detecting changes in groundwater or faint, slow tremors that might precede big events. While no single method can predict earthquakes, combining data from multiple sources gives a clearer picture of seismic risk. The goal is to understand where and how stress is accumulating, not to predict the exact moment of a quake. This ongoing research is crucial for improving hazard assessments and preparedness. Japan's investment in seismic monitoring is unmatched, reflecting the nation's commitment to staying one step ahead. Listening to the Earth's whispers is the foundation of Japan's resilience strategy. Despite technological advances, predicting the exact time and place of a major earthquake remains impossible. The processes that trigger quakes happen deep underground, beyond our direct observation. Faults are complex, with stress and friction varying along their length, making each rupture unpredictable. Scientists have searched for reliable warning signs, foreshocks, groundwater changes, even animal behavior, but none are consistent. Most large earthquakes strike without clear precursors, and false alarms can cause panic and erode trust. Instead, scientists focus on long-term forecasts, calculating the probability of a major quake in a given region over decades. For example, there's a 70–80% chance of a magnitude 8–9 quake along the Nankai Trough in the next 30 years. These are risk assessments, not predictions, guiding preparedness rather than evacuation. The challenge is not knowing when, but being ready at all times. While exact prediction is impossible, Japan's earthquake early warning system provides crucial seconds of advance notice. The system detects fast-moving P waves from an earthquake's epicenter before the destructive S waves arrive. Seismometers instantly relay data to computers, which calculate the quake's location and magnitude. If the quake is strong enough, alerts are broadcast nationwide, on phones, TV, radio, and public announcement systems. These precious seconds allow people to drop, cover, and hold on, and trigger automatic safety measures like stopping trains and elevators. The farther from the epicenter, the more warning time you get. The system isn't perfect. Those near the epicenter may get little or no warning, and false alarms can occur. But during the 2011 Tohoku quake, millions received alerts, saving countless lives. Japan continues to refine and expand this technology, including seafloor sensors for faster detection. The EEW system is a model of rapid response, turning science into real-time protection. Japan's earthquake safety is built on engineering, regulation, and a culture of preparedness. After disasters like Kobe, building codes were strengthened, and modern structures now use shock absorbers and tuned mass dampers to withstand shaking. Infrastructure, bridges, highways, railways, is regularly inspected and retrofitted to meet strict seismic standards. Utilities use flexible pipes and automatic shut-off valves to prevent fires and leaks. Public education is key. Children practice earthquake drills from a young age, and National Disaster Prevention Day involves millions in coordinated exercises. Local governments stockpile emergency supplies, and neighborhood groups organize to check on vulnerable residents. This multi-layered approach ensures not just survival, but rapid recovery after a major quake. Preparedness is a societal commitment involving everyone from engineers to school children. Japan's resilience comes from combining cutting-edge technology with community action. The nation's readiness is a model for living with constant seismic risk. Personal preparedness is vital in earthquake-prone Japan. Every household should have an emergency kit with food, water, first aid, flashlights, and important documents, enough for at least 3 days. Secure heavy furniture and appliances to walls, move heavy items to lower shelves, and install latches on cabinets to prevent injuries during shaking. Know how to shut off your home's gas, water, and electricity. During an earthquake, remember, drop, cover, and hold on. Protect yourself under sturdy furniture or against an interior wall. Don't run outside. Most injuries come from falling debris. Make a family emergency plan with meeting places and an out-of-area contact. Discuss the plan with everyone, including children, so all know what to do if separated. Community involvement is crucial. Join local drills and preparedness groups. Being ready is empowering, turning fear into action. Preparedness saves lives and helps communities recover faster. In Japan, readiness is a way of life, not just a precaution. Japan's relationship with earthquakes is one of respect, innovation, and resilience. The constant threat of the big one drives scientific research, engineering advances, and community preparedness. Every earthquake provides new lessons, leading to better building codes, warning systems, and disaster response. The memory of past tragedies inspires a national commitment to improvement. Safety is a shared responsibility. Governments, scientists, and citizens all play a role. Simple actions like securing furniture and practicing drills transform vulnerability into resilience. Preparedness is ingrained in daily life, from classrooms to offices. Living on a fault line is permanent, but Japan shows how to adapt and thrive. The nation's story is one of facing natural hazards with science, education, and unity. The earth will keep moving. The challenge is to live in harmony with its rhythms. Japan's example teaches the world how to be ready when the ground begins to shake.